Welcome back to Game Code Lesson 2.3. 2.2, we left off with the mom wink. Um, if we were to go further into the story, he makes a couple more partial winks, and then what he does is program the F keys to do sort of an animation. Because if you notice the animation I did with the one blinking eye, it doesn't look all that real. I mean, it's eye open, eye closed, and in this he goes further into it, and um, OK moves between the files smoothly. He examines the wink. Did the two extra files make a difference? He asks himself. I wonder. It does. It does. Now, can I make the machine move between the four files? OK thought, ate, and thought some more, but figured little. Suddenly, he remembers the amount of arrow keys he can run. They moved as magic. OK blind-like presses run, F1, F2, F3, F4, F5, enter. A slow animated wink begins to take place. OK is super excited and figured speeding up the wink could wait for the future. For now, he found animation. I must create more files. This is where it's interesting, and this is in part why I wanted to go over the story and make these game code videos. Is that it's not so, the word run is not so easily seen as anything but a word. I mean, with the arrow keys, for instance, and the ability to press enter. This story, TV Snow story, it goes further into him making, an actual game, a math code game, and some of the concepts are in that game, like, for instance, running, a file. But the thing is, once you get the code in here, all perfect, I mean, the trick is in ways to leave it so that, run is a matter of pressing enter. And then it would run through the file, run through the folder, or the code pretty much. So here's kind of a simple one where he's got F1, F2, F3, and F4, and F5. And this is going to make a sort of a winking animation. I mean, in a theory, in a small, way of looking at it. Probably wouldn't in reality, but it could. So like with the arrow keys, if we back up the story a bit, there's this idea with the P2, that his block was moving, a couple spaces over here, and then it'd move a little bit down. And so that was something that could be run, without pressing enter, if he loaded a P2, it doesn't necessarily mean that the file was run yet, if he loaded it, and then the next command was to run P2, it wouldn't run P2, unless somebody pressed enter. If everything was saved, so that way, once it was loaded and he pressed enter, say a pop-up screen that was loaded and said you want to run this program, it would not run unless you press the enter button. And that's because in that little package, it was saved without having been run yet. So that one, in part why I wanted to make these game codes, is because I find that very interesting, to type the proper code, and then have it do something in the computer, as almost like a magic in a sense, where you get this almost like a little movie playing by pressing enter. So if we go further now into chapter 4, this one's important files. The title of this one is First in Line. This one is just as interesting as the run thing. This one, OK, makes a line. He was first in making lines, on the computer. Lines aren't, technically there. You have words and pixels that you can play with, but a line, to put a line here have in different colors. I mean, say you want a white line right here to underline something. I mean, that's a type of a code that would have to be typed, and then it would have to be run to put the code here, or put a line here, or put a line here. So that's what this um, study will be about. This particular game code. So I'm going to just read up from the top here. For 5 years, OK created files for 5 years, in which time he created the vertical line and the horizontal line. He is copyright owner of a line, the horizontal line, white line, that was and can remain in the center of his monitor, and a vertical line that towered to the heights. Not only did he create the white line, but he over time created a variety of colors for the line. For instance, to load OK's created blue horizontal line, the command is load B-line enter. This will load a blue horizontal line OK created with tiny blocks. As OK worked into the years, he began to develop riches in doing things, like the pre-made line, the one OK could place anywhere on the screen with a simple command. This creating, he had more, his work multiplied. Displaying lines on the television takes time. Each block must be typed. And then there's a little example. Adding through the arrow keys to the line that was to be created. Without perfect aim, OK, and loading a file will cause the codes to collide, and this code will not load over a code. The arrow keys must be used to load blocks, files over files. The space must be empty space to load work into it. OK shall not mix words as one. OK understood himself. He understood what he wanted, an entire virtual universe. He had not made any plans to go home yet, except possibly to pick up his friend WR. That is if WR could understand such possibilities as time travel. OK created every possible line on the screen, with every possible color. Easy to remember, easy to type. Every vertical line running across the screen from top to bottom will be code V line 1. Lines 1 through 95 can make a vertical line roughly anywhere on the screen. To change the color of the V line will be load BY line 3 enter. B for blue, the color of the line in the command will go before the V. Similar are the horizontal lines. Load H line enter. Lines 1 through 95 will make a horizontal line anywhere on the screen. To change its colors are like the vertical lines. Load BH line enter. This for blue. The color of the line will go before the alphabet character H. So this is, in a sense, I mean, cubing a book, for instance, or cubing, a 3D, image, or say, I mean, you have a 3D world or a 3D square, and you want to put your character anywhere in that 3D room, and you have to say file after file after file, so that way it almost, this mouse cursor moving like this, I mean, I don't know if it's true, but the way that one could create it is to do the line thing where you cube this space here that it's moving in, and so that the title first in line was that he could put a line anywhere on the screen, and these lines 1 through 95. I mean, say to fill a screen with lines. I mean, say there's kind of a grid where you got 95 here and 95 up here. That's the area, and so, he'd put the line here and name it, in a structured way, so that way it was almost like a mouse moving. It would be like almost like a mouse moving across the screen, so that way if he wanted to put a line here, he could. If he wanted to put a line here, he could. Further into the story, he does the same thing with fonts and characters. So that way he could, like, for instance, take this F and he could put it anywhere that he wanted to. I mean, say if he was making some art and he needed the F, he could put that anywhere on the screen. So that's pretty much, it's cubing the space or moving through the area of the space. I think it's in 3D. We would cube it, and in the 2D space here, we would you know, just do the area of it. But it's still quite a bit of code because I mean, you know, each line, you know, would have to first be created and then be saved, and you know, then be able to, you know, you'd have to be able to remember where the line was and what the name of the file was. So, you know, I mean, in mind, and you know, I mean, he would know what a square was. I mean, he would know how to change from, you know, alphabet to square. He'd remember the command. You know, it'd be run, you know, plus S plus. I mean, yeah, S plus, and then the color. So, you know, to make these lines, he'd obviously remember his own code file names. So I mean, if he was somewhere around here, he'd probably do, you know, a you know, like a 35 or something, where you load a red horizontal line. Ours for red here, so it'd be like down here, load horizontal red line, and then a red line would show up down here. Um, so, OK found this system easy to work with. He's inspired to do more. I will create my own alphabet, one that I can size to my liking. OK named his first block font words I use. Creating every possible size character would have taken too much time at the beginning of OK's adventure, so he skipped out on most sizes that look like the beginnings of his creation. OK not only wanted to create the size of his characters, but also the space to where the letters would go. Size code is 1 through 50, and placement both for horizontal and vertical are 1 through 95. Code being, you know, load, C's probably for character here. Well, I'm pretty sure it's for character. You know, it's almost like I didn't write it, but I did write this. But, you know, I mean, as time goes on, it's almost like looking at another's work, but, you know, it can offend me that I don't have power over my own work. So it's a bit frustrating because I'd like to let it be loose about it and know. But I mean, this is a big book, so it'd be easy to say, you know, say somebody else did it, but they didn't do it right now in my mind, and it'd offend me if you know, I mean, say you know, you wrote this and then pretended it under somebody else's name, and somebody came along and said, well, I'm that guy, you know. And you'd have to go to law somehow and prove that, you know, prove that you made a couple characters for yourself so you could move around in your space. It would just be really frustrating. So you know, C's for character. You know, there's no way I could remember this entire book in mind. You like that? I mean, there's just no way. So C's for character. C meaning the alphabet character 25. So character, and then you know, character 25, and then 80 for the horizontal placement, and 10 for the vertical placement. So he's pretty much, you know, doing a what they call a you know, the coordinates in a sense. I mean, if you've seen the Earth maps and the coordinates, it's not coordinates. It's Earth map and the I think it's coordinates. Yeah. So I mean, it's similar too, but he's not working in a 3D Earth sense here on a map. Um, but I mean, close enough that, you know, it's almost like a map, and he has, you know, vertical 95 and 95 this way, and then size of the characters, the font size, he only had 1 through 50. You know, and he's going along and he's typing every piece of code for you know, I mean, if he wanted to take this F, like for instance here, I could, you know, in a sense, I could cut this F, and then if I go down here, the computer would know that I just put in an F in there, and you know, um, in a sense, I mean, that's, you know, a way of looking at it. Or even if I press enter here, at the first in line, see how it falls down here? That means the computer read to delete the first one and go with the second one. It's in a way too. I mean, it's like you know, the fourth dimension time travel, where you have all possible Earth planets out there, and then, you know, I mean, you know, one planet right then didn't have this creation in it, and it did have this one. You know, it's and then you know we go back in time, and it's still sitting there. You know, so it's something to that sense, which is awesome, but it's also very, very complex, and I'm sure it would be even harder. I mean, if you had entire Earths that you were somehow cubing, I mean, that would almost be impossible. I don't know if anybody's seen the Backrooms videos, but in a way that complex, you know, or you know, environment, you know, where you're back there, and you know, I mean, any little move, you know, I mean, you're technically not gonna know which Earth you went to and how to get back to your original Earth, and you know, it's I find it pretty neat, but it's also, you know, just a lot of code. I mean, and it's just it's probably worse than finding a needle in a haystack, because I mean, there's just no way to there's no way to there'd be no way to even figure out basically anything. So I mean, once you're back there, you're pretty much going to be lost for a while. And if you ever did get the lotto back there and pull the needle out, I mean, there's probably there's no knowing about it, because I mean, there would be no knowing about it because they're very, very similar. It'd be very, very similar. Okay, so RK reflects towards achievement. I bet I can do more. Like, what if I change the motion of the characters? What if I create them to be able to rotate upside down or sideways? And this will take a while, RK says to himself. He begins by creating a degree scale. For instance, if an alphabet character was upside down, he named it 180. 0 through 180 was upside down. I mean, this type of work right here, you know, I don't know. I've written a couple published books, and it's, for me. I mean, when I was looking at it, you know, even 18, 19, 20, 30, 20, 30 years old, looking at publishing a book seemed like it was so far, you know, beyond my reach that it was impossible. In ways, it still is. But I mean, to think about this idea of a font that you can put anywhere on a 2D screen, um, and then be able to rotate it as well. It's, in ways, it's almost a lifetime achievement in a sense. I mean, it's a lot of work. And I mean, if you did have a code for it, you know, I mean, the entire code written up that you could run, and then make it easy so that way people could as well use it as well, the fonts, you know, where they could put that font anywhere in the screen. I mean, this is an incredible achievement. And it would take a lot of work. I mean, you're gonna have a lot of code in there to do that, and you know, and then looking back, I mean, if something went wrong, you'd have to make sure it was perfect. And if you wrote the code too, I mean, it's not even a book at this point. I mean, that type of an idea is not even a book. I mean, it's it's probably hundreds of times harder to do than a book, you know, a published book. Hundreds in my mind right now. I mean, but I could be wrong, but I think with a book, a published book, you just come up with a story, write it down in a format so people can read it. I mean, with the code, you're pretty much writing something, um, you know, like for instance, putting a line anywhere on the screen. I find that would be quite a bit harder to do. I mean, because a book could take 1 to 2 years. Putting the code anywhere at first, it could take. I believe it could take more than a couple years. So I suppose that will end this one first in line. I'm glad you joined along. How long are we going? This is about 20 minutes now. But here we are. We're on, you know, in you know, the game, the Undercover AI project. You know, the blurb copy. I'm pretty sure it's on GMC Drawings by Brendan. We're around one page 154. There's a lot of good stuff in here. A lot of stuff to think about. So you know, don't let me hinder your studies. I mean, the book's on the website. You can download it for free and have fun digging in and questioning. I mean, how could that work? Have a great day.